Math and Beats, more videos. In this video, we're going to talk about deleted neighborhoods. Let's take a look. All right, a deleted neighborhood. Let's let x be some real number. Then we say that a deleted neighborhood of x with a radius of epsilon is a set which is defined to be this set right here. What is that set? Well, it looks very similar to a neighborhood of x with a radius of epsilon, except there's one difference. First, the notation, we just put a little star here to indicate the difference between a neighborhood of x with a radius of epsilon and a deleted neighborhood of x with a radius of epsilon. The big difference, besides the notation, is that in our collection of values that we have here, not only do we need the magnitude of x minus y to be less than epsilon, which we're assuming to be a positive number, we also need the entire magnitude to also be positive. You may recall that when we talked about the regular neighborhood of x with a radius of epsilon, the magnitude x minus y could be 0, but in this case it cannot. And that's the real difference. Let's dissect it a little bit more. Let's go ahead and just solve the inequality within the set, which provides the restrictions on the relationship between x and y. And that is, solve this inequality right down here. So that's what this is showing. All right, we'll start with the inequality. Now, what's that mean? It means the same thing as saying x minus y is less than epsilon, but it's also greater than negative epsilon. Now we're going to isolate our y's since the set consists of all the y values. That means we're going to subtract x on all sides of the inequality to get this. Negative epsilon minus x is less than negative y, and that's less than epsilon minus x. And then finally, multiplying through by a -1 gives that these y values really need to be trapped between x minus epsilon and x plus epsilon. But because we need this restriction here, we know that y cannot be equal to x. And so this provides for us the inequality that we saw above and produces the set in interval notation here, which is what I just circled. And that is, go all the way from x minus epsilon up to x, but then we don't include the x, and then we just keep going after that x all the way to x plus epsilon. So let's draw that using a little line graph here. These are x values. So where is x? I don't know, there's some x right there. Where is x minus epsilon? Somewhere down here, where this distance is epsilon. And then x plus epsilon is up here somewhere. Again, distance of epsilon away from x. So what we're saying now is include everything between x minus epsilon and x, and then also include everything from x to x plus epsilon. But we don't include the x. Hence, we must union the first interval with the second. And that is really what a deleted neighborhood is of x with a radius of epsilon. If this was just a neighborhood that was not deleted, then we would include the x. And that's the big difference. So this is all said right down here. Everything we just stated. Deleted neighborhood of x with a radius of epsilon is the collection of values, column-wise, so that the magnitude of x minus y must be less than epsilon and bigger than 0, which is the same thing as saying take all the values between x minus epsilon and x plus epsilon, but do not include that center x. Let's look at an example. Let's find the deleted neighborhood when x is 2 and epsilon is 3. We'll do it by just starting with what we know, and that is here in this case, the deleted neighborhood we're looking for is about x is 2 and with a radius of epsilon is 3. So using the inequality within the restrictions, we get that we're looking for a collection of y's so that the magnitude of 2 minus y is less than 3 but positive, which is the same thing as saying the collection of these y values, noting that y cannot be equal to 2, right? Y cannot be 2, which is the same thing as saying, okay, subtract the 2 everywhere on all the sides. We get negative y should be between negative 5 and positive 1, and therefore positive y is between negative 1 and 5, but y cannot be 2 anywhere here. So, therefore, we get the interval negative 1 to 2 union with 2 to 5. All the values between negative 1 and 2, 2 being the center, and all the values between 2 to 5, notice that the distance from negative 1 to 2 is epsilon is 3, and the distance from 2 to 5 is epsilon is 3 as well, and we do not include the 2 since that is where we are centering our interval. Graphically, just want to show you real quick before we end the video, the difference between, say, n of 2, 3, the neighborhood of x is 2 with a radius of epsilon is 3, and the deleted neighborhood 2 and 3. What's the difference? Both of them are centered at x is 2. On the top, we're going to move epsilon is 3 units to the left and to the right of 2, which leaves us at negative 1 on the left and 5 on the right. So this interval is actually just all the values between negative 1 and 5, but not including the negative 1 and 5. But we do include the center 2, whereas the deleted neighborhood about x is 2 with a radius of epsilon is 3, we still move out epsilon is 3 units to the right and to the left, which leaves us at the same locations of negative 1 and 5, but now we don't include the 2. Hence, this is the interval negative 1 to 2, union 2 to 5. So hopefully that helps you understand the difference between a neighborhood and a deleted neighborhood. And from here, we will keep going with this discussion. And the next thing we're going to talk about is something which is called an accumulation point, which requires us to know what deleted neighborhoods actually are. That's the end of the video. Hope it helped. Now it is your opportunity to hear a short beat. Later.